Okay, let's take a look at question 1 here for our second exam review. Start off, this is my work. So we're looking at a population problem that we are told a population that's increasing by 1.8% every 3 years. We're given the population of what it was in 2012, but the variable we're going to use is going to be n. Remember, population growth is exponential, and that is the year since 2009. So this year, 2012, is actually, 3 years down the road. When n is 0, it's 2009. Okay, so let's start looking at these questions we have. So what is a 3-unit growth decay factor? So a factor is what we will multiply by. It involves the percentage. Since we're increasing, we're getting all the folks back that were there last year, so that's the 100%. We'll put the decimal point there. We're growing by 1.8% every year, so that means we're adding on 1.8% of that not every year, every 3 years. And so our answer is going to be, we just add these two together, we get 101.8%. But that's not a factor, that's a percentage. To make it a factor, a number, we divide by 100. And that's going to give us the answer of 1.018. So that's our factor. What is the 1 unit percent change? So now we're talking percent change. So this is every 3 years. What we're going to do is we're going to take a cube root of that. Let's change our color a little bit. A cube root of 1.018. And then since they want a percent, we're going to, once we're done, we'll change it back to a percent change. So let's come over to our calculator. And we're going to do a cube root. We have a square root here, but if we go to the math key, we will see that there is a cube root number 4, and number 5 has the x root. So if we needed to do, like, if it was a 4-year change or 5-year change, we could do that one. But since it's a 3-year change, we've got this built-in cube root of 1.018. So that's going to be 1.0059. So we can come back here. I don't know how many decimal places they want us to show. But they want it as a percent change. So here we will multiply by 100. Okay. And they just want the amount of the change, not the 100% we've got. So we'll do this. So if you divide by 100, multiply by 100, it's going to be 100.596. That's now a percentage. 100 is what we're getting back. The change is just the 0.96. And so for this answer, we'll go with 0.596%. Not even 1%. So that's the answer for the B part. What is the half unit growth decay factor? So since we've got the 1 unit, half of that would be a square root. So we're going down by basically half a unit. So we can take the square root of the number that we have right here. So let's do that. We've already got it in here. So a cool way to do this is we could just say, let's take the square root of the previous answer. And what you see here is, where's the answer? There's entry, there's answers right above the little negative sign. So I go second answer. It brings that answer, the last answer, in there. Hit enter. And so a half unit growth decay factor is going to be this 1.002977777, however far out we need to go. Oops. Just wanted to go here, go back to the pen. Oops. She gave me a new page. I didn't want a new page. Okay, so growth decay factor, what we're doing is we're taking the square root 1.00596 and we are getting 1.0029777. So let's round that up to 8. Basically with exponentials, as long as we got 5 decimal places, 1, 2, 3, 4, 5, we'll be accurate enough. 4 sometimes works, it just depends on what you're doing, but definitely 5 you won't really be able to see the difference between going to 5 and 6. So what's the approximate population in 2009? Well, what you have to realize is they give us the year 2012, that's 3 years down the road, so it has been increasing for 3 years. So the way we can do this is take 8,624, the population in 2012. If we wanted a future value, we would multiply this by the growth decay factor, 1.018, multiply it by it. If we wanted 3 years into the future, multiply. What's the opposite of multiplying? Dividing. So if we divide it by the growth factor, that will give us what the population was 3 years previous. So, oops, not that. Let's go ahead and clear this out. 8,624 divided by 1.018. So that's telling us, and again, what we were expecting is it should be smaller because population is growing, so in the past it would have been smaller, and in fact that's exactly what we get. We get 8,471 people, 0.51. I guess we'd round it up to 2. You can't get half a person, but sometimes the mathematics gets more precision than is warranted. I forgot to circle this one. Okay. So then now we're asked to write a function, and we have all our pieces. This is when the population when n equals 0, right? Number of years since 2009. So this is our starting value. We have a 1% change, certainly, but more importantly, to get that, we got the one unit change factor. So we kept that. That's why I underlined it in red. This is an important number we're going to use in our formula. And then we have our value for n. So what is our function? Let's see. Let's go with dark green. So our function is going to be something like p of n. So our input variable is the starting value in 2009 of 8,471.51. And then each year that we get growth, we're going to multiply by the 1 year factor. And we're going to raise that to the n power. Now, alternatively, we could also set it up with the 3-year growth decay factor. And that's what's in the answer key. So I'm going to highlight that. No, I didn't mess it up here. I'm using the 1 year because, that's the way, we might not want to just count by every 3 years. This other formula will handle it as well. So 8471.51, same starting value, but we can now use the 3-year rate, the factor, 1.018, but our exponent is not just n, it's n divided by 3. And that's the 1/3 power that we're using to find the first year. So I kind of prefer to keep everything standardized, and so that my base factors are always 1-year growth rates. And that's the way we do it. So now we want to determine the number of years it will take for the population of Northfield to reach 9,172 people. So what we're trying to solve here, or solve for, is when will P of n, the output, when will it be 9,172 when we start with 8471.51, and we're growing by 1.00596 raised to the n power. I'll show you the graphical way we can do this. You can also do it algebraically. I'll show that sort of as a secondary way, but graphically what we're going to do is we come to our graphing calculator, we'll go to y equals. We're going to clear out what we've got here, and this is kind of a nice way because you can solve any equation around. So what we do is we graph, we're going to do a graph of the left side and the right side, and where those two graphs intersect is where our answer is going to be. So if you want, you can start with the left side. That's just y equals 9. It's a constant, right? 9,172. So we put that in. That's going to be a horizontal line at 9,172. So we'll talk about that more later. Second, y is going to be the right side of the equation. 8,470. Oops. Back up. Let's just delete that one. 8,471.51. Put parentheses, that implies multiplication. 1.00596 parentheses, and we'll raise it to the x power because and there's just this variable key up here, so it will use the variable that the graphing thing uses. Now when we go to graph this, we've got to see we're up at 9,000, right? We're starting at 8,400. We're growing. So when we hit the graph button, depending upon what our window is, we may not see anything. So where I'm going to go back is go to window. In fact, actually, what I'd like to do when I graph is I go to zoom number 6, which is sort of the factory default, the standard, -10 to 10, -10. So at least I know where I'm at. I don't see any graph, but that's not surprising. So I go to the window. I want my minimum x probably to be 0. So x minimum, let's just put that as 0 because we're not going back in time anymore. That would be year 2009. I don't know how far into the future. Remember, your x value is going to be years. Let's just go with 20. Hopefully we've got it captured in there. But here's where we go. Y minimum. We know we're starting at 8,400. So let's have the y minimum be 8,000. And we won't see the x-axis, but that's okay. How about the y max? Well, we're going to 9,172, so we don't need to get much bigger than that, but how about 9,500? Now, when we hit the graph button, we should see our graph. And we certainly do. And the nice thing is we've got these color versions. If you have the color calculator, it'll show you those. You can actually choose which colors you want, but this is Y1, 9,172, and the red one is our growth function. So to get the intersection, we go second. There's above the trace key, it says calc. There's a tool in here that says intersect. And it's a real nice tool to use because it jumps to one of the lines and it's asking the question. There's a question mark here. It's asking if this is the first curve. And we're just going to say yes it is by hitting enter. Then it jumps to the second curve and asks, is this the second curve? Because you could actually have multiple curves. We'd have 3, 4, 5 of them. But we only have 2, so that's good. We just hit enter. And then for the guess, you could use the arrows to move it closer, but you really don't need to. We're close enough. We can see it. if we hit enter, the calculator will find it pretty darn quick. And it gives us an answer here that y is 9,172. Actually, I can see it over here. When x is 113.96, 13 point, what is that? 36, 369. Okay, so now I can come back here and we have solved that n equals 13 point, we'll round it to 37 years. Now remember, the test is multiple choice, so you just need to be able to choose the correct answer. Let's also take a look at how we would do this with algebraically. And again, at this point, if you're satisfied, and you know what, you're able to go ahead and do that. This is the sort of the extended version of the lesson, and hopefully this is, but it got you to an answer. And again, graphing is a perfectly fine way to do things. Let me see. I'm waiting for my Word document so I can have plenty of room to work with. Okay. Bring it over here. Get that the writing's on top, but I'm going to delete all of this here in just a moment. So take a quick look. If you want to take a screenshot, it's there for you. What I'm going to do is I'm going to write down, I'm using slightly different tools, I'm going to write down the equation 9,172 is equal to 8471.51 100596 to the n. And then I'm going to, actually, I can get a new page, right? Just like I did last time. Let's go for a new page so we can come back to that last page. So let's this is our page, and now I'm using the word tools. Actually, let me let's see, close that one. I want to be able to see the calculator because I'm going to need it. Okay, so to solve this equation algebraically, I want to isolate the exponents, so I'm going to divide both sides by 847151. 847151. Let's get back to the main page. The way I do this, I go second quit, and it takes me back to the main page. Let's just clear it out. 9172 divided by 8471.51. And again, you could do this calculation at the very end because again, you get a lot of decimals. But again, as long as you use 5 of the decimals, you'll be fine. So that's 1.0826 1, 2, 3, 4, 6, 8, but that gets rounded up to 9. Okay, and then this is just 1, so those canceled out, and we're equal to 1.00596 raised to the n power. And now what we're going to do is we're going to take the natural log of both sides. And the reason we do this is because log properties say that the exponent can come down in front. So this is the only algebraic tool we really have, is to take the natural log. What that's going to do is then we can use the logarithm properties and the exponent will come down in front. So then we get the natural log of 1.0826 I'm going to put a parentheses around that, equals n times the natural log of 1.00596. And then all that's left to do is to get the n by itself is we divide. See, we were multiplying, so the opposite of multiplying is to divide. Natural log of 1.00596, that's going to cancel out and be just 1, right? 1n. On this side, we do the same thing. Have to do the same thing to both sides. So you take the natural log of of this divided by that, and that's going to be our value for n. So let's do that. Come over to the calculator. We're going to take the natural log, that's ln right here. And notice it gives us the parentheses, so that's good. 0.8269. Now it's very sensitive to decimals. If we enter something wrong, then it's not going to work so well. Divided by natural log 1.00596. Now, had we used the equation with n divided by 3 when we're done, we haven't actually isolated right there. This would be n divided by 3. We would then have to multiply by 3. So if you did it that way, that's okay, but you just would have an extra step. This is why I like using the 1 unit factor. So we get 13.3700. Okay. Same thing we got with the graph, so we can recognize the answer either way. Either way is going to work. Okay, so that's question number 1. I'll take a break here, and then I'll do the next one.